Good morning, grade 11s. Today's lesson is on trigonometry applications. I will be doing two examples with you. This will be our last lesson for Math 11. Two boats leave the dock at the same time. Each travels in a straight line but in different directions or locations. The angle between their course measures 54 degrees. One boat travels 40 kilometers in 1 hour and the other travels 53.6 kilometers in 1 hour. Find the distance between the boats after 1 hour. So to start off this question, I need a diagram. So I have a dock. Okay, from here, that's my dock. One boat is traveling this way, and the other boat is going to travel this way. I know the angle between them is 54 degrees. So one boat travels 48 kilometers. The other boat travels 53.6 kilometers. They want to know the distance between the two boats. Once the boats reached here and the other boats reached here, we can call this boat 1 and this is boat 2. What's the distance between the two boats? So that would be my triangle. And now looking at this triangle, we know it's an oblique triangle. So we have to use either the sine law or the cosine law. So looking at a diagram, and if we look at a diagram, we'll notice that we can't use the sine law because we don't have an angle side pairing. So our best thing to use is our cosine law. So if you look at the answer, the question mark, which I'm going to make x squared, is going to be equal to 48 squared plus 53.6 squared minus 2 times 48 times 53.6 times cos, and my angle is 54 degrees, so 54. So that's my sine law. I'm going to multiply these two numbers first. I'm going to multiply those numbers first, so I get x squared is equal to 48 squared plus 53.6 gives me 5,176.96 minus, if I multiply 2 times that, it gives me 5,145.6 cos 54. Now I'm going to multiply this. X squared is equal to 5,176.96 minus 3,024.51. Now if I subtract them, x squared is equal to 2,152.45. My last step is to take the square root and take the square root. So x is equal to approximately 46.4 kilometers. So the distance between the two boats is 46.4 kilometers. Example 2. Traveling to Jasper from Edmonton, you notice a mountain directly in front of you. The angle of elevation to the peak is 4.1 degrees. When you're 21 kilometers closer to the mountain, the angle of elevation is 8.7. Determine the height of the mountain. So your first step is to draw a diagram. So I'm right here. I'm going to make this my starting point. I'm standing here, or my car is there, and I see a mountain. Okay, when I look from here to the top of my mountain, sorry, that's not the best. To the top of my mountain, and this is the ground, that's my road. The mountain comes all the way down. This elevation here is 4.1, my angle. Then I keep driving and I stop my car. I've driven 21 kilometers. And then I again look to the top of my mountain. And this angle here is 8.7 degrees. Okay. So now that's my diagram. So this is my initial elevation to the top of the mountain. Then I drove 21 kilometers. That's my second one. I need to find the height. This is my height of this particular mountain. So how do I solve this question? So if I look at it, I have one big triangle, that's a right triangle, but I don't know the entire distance. So I can't solve for my hypotenuse because I know the angle, but I don't know this. I also have an oblique triangle and another oblique triangle inside. So what I can do is I can figure out my angle. I can figure this angle here. I can figure that out because angles on a line add up to 180. So I know this angle here is going to be 180 degrees minus 8.7. And if I go 180 minus 8.7, I get 171.3 degrees. So I know this angle here is 171.3. If I know both of these angles, I can find this top angle here, because 180 minus 4.1 minus 171.3 is going to equal 4.6 degrees. So I know this angle here is 4.6 degrees. Okay, so I figured out these three angles. Why was that important? Because now I have an angle side pairing. Because I have that angle side pairing, I can use my sine law to solve the common side of my triangle. Because this here is the common side. So if I can figure out this distance, I can figure out the height of my triangle. So if I use my sine law, this angle and this side, and the angle ratio that's known, so I can go sine 4.6 over 21 kilometers is equal to sine 4.1 over, and we'll call this Rx. Rx. So I can solve for x, which is my common side. I cross multiply and divide. So it becomes 21 times sine 4.1 divided by sine 4.6, and that'll give me my x. So if I plug all that into my calculator, I get 18.7 is equal to my x. So now I have figured out that the common side, this here is 18.7. Once I know that's 18.7, I'm going to erase this part now. Once I know that's 18.7, I can look at this triangle in here, which is a right triangle, to find my h. So I would use my trig ratio. So I'd go opposite over hypotenuse. So sine angle is 7 is equal to opposite over my hypotenuse. Then the same thing as being over 1. I cross multiply. 18.7 times sine 8.7 is equal to my hypotenuse, or the height of my, not my hypotenuse, the height of my triangle, which is 2.8 kilometers is equal to the height. So this particular question is 2 steps because there's 2 triangles you're using. So if you have any questions, please email me or send me a message on Teams. On Thursday, you'll be getting your trig assignment. That assignment is due by Friday, 10 a.m. If I don't get all missed work by Friday, 5 p.m., I will not be marking it. Thank you.